Today we're going to be talking about the Weasley family pedigree and the pattern of inheritance for the trait of ginger hair. So this is my hand-drawn pedigree. Here we have 3 generations of Weasleys and some outside family matings. We have Molly and Arthur, the parents of the Weasley family. We have Ginny, Bill, Fred, and Ron. Ginny and Harry have produced James, Lily, and Albus, while Ron and Hermione have produced Hugo and Rose. So is this pattern of having ginger hair halandric? Is it carried off on the Y chromosome? We can tell here in Ron and Hermione's mating that it is not, because Ron has a son, Hugo, who also has a Y chromosome, who received it from Ron, and Hugo does not exhibit ginger hair. Is it autosomal recessive inheritance? It's not, again, with Ron and Hermione, because, and since we don't know anything about Hermione's family, we can't assume anything about her genotype. We know that she doesn't have ginger hair, so we know she has one big R, but in order for this specific system to work, she needs to be heterozygous, so she can give one big R off to Hugo, who does not have ginger hair, and one little R off to Rose. If she is homozygous dominant, it does not work. Ron has to be big R for all of this to work. If it's X-linked recessive, it won't work either, because Harry gives off his Y chromosome to James and Albus, which means that they must get an X chromosome from Ginny. Ginny only has XR, and in order for, or X lowercase r, in order for James and Albus to not be ginger, they must have a big R, but instead they only have little r, so this doesn't work. Autosomal dominance does work, and you can tell here if you follow through on my markings that it indeed does work. Now, X-linked dominance also does work, and again, you just have to realize that we don't know much about Hermione or Harry here, but we do know, because it's X-linked dominance, that they have to have a little r, so that's why you see that in this specific pedigree. Here are my citations for images, and all of these hand-drawn pedigrees are my own. Thanks so much.